Hey guys, this is the video for day 4 of our chapter 8 of chemistry. You've just taken your quiz and we are about to start section 8b, which we're looking at the next couple days and then practicing. And it covers naming compounds. Now there's going to be a set of rules that tell you how to name the compounds, but there's going to be two different sets of rules depending on what type of compound you have, whether it's covalent or ionic. You'll also be doing some section review problems for homework tonight, but I'm going to adjust this a little bit. We won't get far enough into section 8b for you to really do all of those problems tonight. So I'm going to move that and make it part of your work tomorrow, and I'm actually going to take off number 4. For tonight, due by tomorrow, just focus on the section review for 8a, and I'll put a place on Google Classroom for you to post a picture of that work. Alright, so let's switch over and start looking at the notes for section 8b. You'll want to follow along on page 8. We're going to look at what nomenclature is, and then talk specifically today about how we name binary covalent compounds. So the word nomenclature means a system of naming, big fancy word, and so for this class, we're talking about the system that we use for naming compounds, and it does follow a particular set of rules. We came up with these sets of rules because in ancient times, leading up to medieval times, we knew a lot about a lot of different chemical compounds, like salt or sugar, different things like that that had common names. Here I have Epsom salt, and the problem is we kept discovering more and more kinds of compounds and elements, and you get a bunch of common names that you would just have to memorize. And the common names that you memorize don't give a good idea to people who are new to chemistry about what might be in that compound. You know that salt is sodium chloride, but do you know what Epsom salt is? It's not sodium chloride. If you can see this subtitle here, it's actually magnesium sulfate. Now, to a chemist, magnesium sulfate is a much more useful name. It tells you that you have an ionic compound with the ion magnesium and the polyatomic ion sulfate, which is one of the ones that you're learning a symbol for. It's SO4. And you'd even be able to write the formula if you had the name magnesium sulfate. So we want descriptive, technical, chemical names for all of these compounds. It gives you a lot more information than a common name. Today we're going to look at just one narrow category of compounds, the binary covalent compounds. If it's not an acid, then you're going to name it with a system of Greek prefixes. Now let's just make sure we know what category we're talking about here. That word binary, what do you think that means? You might recognize the prefix bi as meaning two, so this is a two-element compound. You'll only see two elements symbols in the formula. The fact that it's covalent narrows down what kind of elements you'll see. They should both be nonmetals. As we learned in the last chapters, that covalent compounds are elements with high electronegativities like nonmetals that share their electrons. And then in the definition here it says that even if you have a binary covalent compound, it needs to not be an acid. So let me give you an idea of how you'll be able to tell if it's an acid. Acids would be covalent compounds that begin with a hydrogen, except if you see the formula for water, that is a covalent compound and it does begin with hydrogen, but it's not an acid. At least not exactly an acid, but we'll get to that in later chapters. So the problems I'm going to give you will just be binary covalent compounds. You'll see two elements that are nonmetals, and you'll use the Greek prefixes. Here's the Greek prefixes from 1 to 10. Most of them should look pretty familiar to you. If you know another prefix that goes with the number, make sure you're using these. For instance, you might see a 4 and think quad, but that's a Latin prefix, not a Greek prefix. You need to use tetra. We're going to use these prefixes to indicate how many atoms of each element are in a binary compound. What will end up happening is that the prefixes in the name match the subscripts that you see in the formulas. You'll need to know, and that means memorize, these Greek prefixes. They're in your book, but I've also printed them in the notes for you. So, here's some of the rules that we use to help build our binary covalent compounds. I mentioned this in a previous lesson, but we usually put the less electronegative element first, the one that would have a positive oxidation number in that case, and the more electronegative element second. So here, nitrogen's less electronegative than oxygen. It goes first, and it ends up having a positive oxidation number if we were to figure those out right now. Usually in the problem, they'll already be in the right order, so you won't have to know to use this during the problems, but it might ask you it in a true-false or some sort of question like that. And then we're going to build the name. So the name, you can see in your notes, is going to start with the names of the actual elements that you see, nitrogen and oxygen, and then we're going to mess around with these names a little bit to tweak them and get them just right. You are going to add prefixes at the beginning of each element's name that matches the subscript for that element. No crisscrossing with covalent compounds. What's the prefix for 2? That should be the prefix that I put in front of nitrogen. And I can see it's di. Again, it's not bi, because bi is a Latin prefix. Di is the Greek prefix. Then we look at oxygen. What's oxygen's subscript? Well, if I can't see it, that doesn't mean it doesn't have a subscript. It means it's an understood subscript, and it's a 1. So I have 1 oxygen, so that's monoxygen. And you'll notice it's not monooxygen. And that's because typically double vowels are omitted, exception being double I's. So, or even just a vowel in front of I, you wouldn't necessarily omit. But if there's a vowel in front of oxygen, like an O or an A that you would put in front of the word oxygen, we'll usually drop that O or A from the prefix so that you don't have 2 vowels right there. We don't usually drop the I's. Now there's one little last tweak that we make to the name, and it's to do with the second nonmetal. The second nonmetal, its name is going to end in IDE, and that usually means you are going to replace the ending that you see with IDE. So instead of dinitrogen monoxygen, we're going to take off the -igen and replace it with -ide. And now we have a really smooth sounding chemical name, dinitrogen monoxide. I've printed a table from your book that gives you an idea of how the element names will end with this -ide ending. For the halogens, it's essentially just replacing the N with a D instead of ein or een, it's -ide. And then we have oxide, sulfide, selenide, nitride, carbide, phosphide. Those are some of the common ones that you're going to use. So you can refer to that table. It's the kind of thing that you'll get used to using. If you, kept too much of the original word and still had the -ide ending, that is not the kind of thing that I'm going to take off for. Since it's if you tried to change the ending to -ide in some way, then I'll give you credit for it. I'll probably correct it to let you know where you went wrong, so that you can get used to how it should be. So why don't you try this one? NO2. What would the name of NO2 be using this prefix system? And the answer is nitrogen dioxide, and you probably said mononitrogen dioxide. Well, like grammar, we have some exceptions to our rule sets here that you just have to get used to. One of the exceptions is that the prefix mono is not usually added to the first element. It is always added to the second element if it's the prefix that applies, but we usually leave it off if it's the first prefix. So instead of mononitrogen dioxide, it's just nitrogen dioxide. So, keeping that exception in mind, how would you name NO? Well, the name would be nitrogen monoxide, because again, this exception applies to the first element, not the second one. So we leave off the mono from the nitrogen, but we keep it in front of the oxygen. And you'll notice that our second element is oxygen in this case, and it ends in -ide, oxide, oxide, oxide. The first element does not end in "ide." All right, here's a few more. Why don't you try these really quick on your piece of paper, pause the video, and then resume when you think you have it. For our first problem, B2BR4, that would be a diboron tetrabromide. Only the second element name ends in "ide." This is ClO2. It's binary, only 2 elements, so that is not an I. So I would have chlorine, leaving off the mono from the first element, dioxide. Now we know H2O is water, but the proper chemical name would be dihydrogen monoxide. You can also use these prefixes to work backwards. You could see the name for a binary covalent compound and come up with the formula. Now you'll know that these names and these compounds aren't going to use the crisscross method because you'll actually see the prefixes there that we're going to use to write the subscripts. When we use the crisscross method for ionic compounds, you'll never see prefixes. So here for sulfur hexafluoride, the first element would be an S with an understood 1 because it has an understood mono. The second element is F for fluorine, and it has a little subscript of 6, SF6. What do you think these next two would be? Dinitrogen pentasulfide would be 2 N's, N2, and 5 sulfides, S5. Carbon tetrafluoride, the carbon is an understood subscript of 1 for the understood mono. Tetra means I have 4 of the fluorine. And that wraps us up for the basics of naming and writing formulas for covalent compounds. You can go in either direction now, and you should be able to use that information for your practice. So, the practice that you're going to be doing is on page 10 of your notes. Look at the section at the top for binary covalent compounds, and they have you going in both directions, looking at the name and coming up with a formula, using the prefixes to write your subscripts, and then looking at the formula and writing the name, using the subscripts to put a prefix at the beginning of each name. Make sure the second element's name ends in "ide." Why don't you try that practice now?